All right, so we are starting 6.4, square root function attributes and transformations. This is going to be page 130 in your handy dandy notebook. Okay. The plan is to do majority of these notes today. Then we'll finish them tomorrow. The exit ticket that's in your notes is going to be your due now for tomorrow. So just heads up. But we're going to do all notes today. Tomorrow we'll finish the notes and then work on classwork for the remainder of class period. Okay. Any questions so far? Cool. So we're going to start off with, just like anytime you talk about a function, you're going to start with its parent function. A square root function is the inverse of a quadratic function that has a restricted domain. Okay, the key thing here is that the restricted domain. If we didn't restrict the domain, it wouldn't be the square root function. It would just be the square root relation. And that's because it would fail the vertical line test. Now, the table representation, these are our smallest perfect squares. That's what your x's are. Your x's are your smallest perfect squares. And so when I ask for the square root of 0, what do I get? 0. Square root of 1, what do I get? 1. Square root of 4, what do I get? 2. Square root of 9, what do I get? 3. So these are our smallest perfect squares. And these are the values that we use when we're typically talking about our parent function. Okay. Our second representation here is function representation. So our function is written as f of x equals the square root of x. And we're saying when x is greater than or equal to 0, meaning that we want no negatives. Okay. Our third representation that we have is of a graph. So graphically, what does it look like? Well, it looks like a little arch. So it's a little arch. And when we look at this arch from left to right, it increases. Do we see it increasing? The domain of this graph, domain meaning how far left do we go? So reading from left, we go from 0 to infinity, which is why our domain is x is greater than or equal to 0. When we're looking at our range from bottom to top, we start at 0 and then we continue to infinity. So this is our domain and range written in inequality format. Our domain and range can also be written in interval, which would be 0 to infinity. Our x-intercept and our y-intercept are asking us, where do you cross the x and y axis? And that both takes place at the origin. Any questions so far about the parent function? We're good? Looks familiar? Okay, cool. Now, the next thing we're going to talk about are transformations. Just like all the other functions, there are transformations that take place, okay? Nothing's changing except the function that we're working with, but it's the same thing as prior to this with our square root, our quadratic, our absolute value, same effects. So first we have our vertical translation. Our vertical translation is going to affect the y values. So your vertical translation affect your y values, which means it's going to affect your range. Okay. So if you have a number that's being added or subtracted outside of the square root, that's a vertical translation. If it's being added, it's going to go up. If it's being subtracted, then it's going to go down. That's why it says D is greater than 0 and D is less than 0, because they're either going to be added or subtracted. Okay. Horizontal translation. Horizontal translation means that the addition or subtraction is happening inside of the square root. Okay. So your addition and subtraction is happening inside of your square root. And this is going to affect this affects your x values. And a key thing we need to remember about our x values is that x's are liars. Okay. So when we see x minus c, that actually means that our c is positive. It's going to be shifted to the right. So it's going to look like a minus, but it means that c is actually positive and it's going to the right. If we saw x plus c, our c is actually less than 0. because that means it's negative, and it's actually shifting to the left. Because x's are liars. All right. Sure. Vertical stretch and compression. Your vertical stretch and compression is changing how quickly or how slowly your y values increase. Okay. So here, when you have a number on the outside of the square root that's being multiplied, that's a stretch or a compression. Okay. So that stretch or compression is on the outside. If the absolute value, meaning regardless of whether it's negative, if it's greater than 1, that's a vertical stretch. If it's less than 1, that's a vertical compression. If you don't want to use the word compression, you can use the word shrink. Okay. And this is going to affect our y's. Okay. Now, when you're taking into the consideration, if A is negative, that's a reflection in the x-axis. So it's going to reflect over the x-axis. So instead of our function forever increasing, it's now forever decreasing. All right, our horizontal stretch and compression. Again, here, x's are liars. Mathematically, it looks like you're going to be multiplying each one of your x values, but in reality, what you're doing is dividing them. Okay, just like here, we look like we're subtracting, we're actually adding. Same thing here. It looks like we are multiplying, but we're dividing. And that's why the effects are opposite. So if B is greater, if the absolute value of B is greater than 1, it's a horizontal compression because I'm dividing the x values. If absolute value of B is less than 1, it's a horizontal stretch. And again, this is affecting our x values. Okay. Reflection. So if your B is negative, it's a reflection in the y-axis, which means that your function is reflecting over the y-axis. So instead of it doing this, it's now going, pretend that as a curve, not a line. I try to make it a curve, but curve as well. Okay, so when we put it all together, the transformation function for the square root function would look like f of x equals a absolute value of b times x minus c plus d, where each piece has a role that it plays. What are your questions about the transformation rules? One question may be, why do I need to know this? Well, transformations are useful when you don't have a device to do the graphing for you. You can do the graphing for yourself and be able to analyze and describe it, which we're going to model here in a minute. It's all right. We all got to do things and deal with people we don't like. Part of life. All right, so we're going to analyze this graph. F of x equals the square root of x minus 1. First, we're going to draw on our axis. So there's my y-axis. And there's my x-axis, and we're going to pretend that those are super straight lines. That doesn't really matter. Okay, personally, the first thing I feel like you should do when you are analyzing a graph is to draw in its parent function. So I'm going to draw my parent function. Remember, the parent function of this are what are our smallest perfect squares and their roots, right? So that's 0, 1, 4, and 9. So I'm starting at 0 because the square root of 0 is 0. 1, square root of 1 is 1. 4, the square root of 4 is 2. So that is my parent function. And I'm asking, and it's asking what is what? Oh. So this is our f of x. And our f of x is saying that we're taking the parent function and we're changing it by subtracting 1. What translation or transformation does that represent? The -1. Is that my a, my b, my c, or my d? It's my d. My d equals -1. It's something being added or subtracted on the outside, right? So I'm subtracting, so d equals -1. And we said that if d is less than 0, that means it's a vertical translation down. Right? So that's a vertical translation down. So what that tells me is that each one of these points in my parent function is going to be shifted down 1. So now it's here, here, here. I went down too much on that one. So here's my f of x. So if you were to look at a table to do this, so remember our parent function table where we had, it said your x's are 0, 1, 2, 4, and 9. And your y's were 0, 1, 2, and 3. What this translation is saying that, remember, it affects your y values. So to each one of your y values, you're subtracting 1, which is why physically we just shuffled down 1. And that puts us at -1, 0, 1, and 2. Does that make sense? Yeah. So we see it physically on the graph, and then do you see what happened on the table? So that's why 0's at -1, 1's at 0, 4 is at 1 now, and then if it would continue. All right, so now we're going to stripe the domain and range. So the domain here, where does it start? Our domain starts at 0 and continues to infinity, right? So our domain is x is greater than or equal to 0. Our range, where does our range start at now? Did someone say -1? Our range starts at -1, but continues to infinity. So our range is y is greater than or equal to -1. Okay, even though it doesn't say it, I want us to analyze our intercepts. So our intercepts, where do we cross the x and y axis looking at our f of x, the red graph? Intercepts. Where do I intersect the graph, the axis? 0, -1, and where else? 1, 0, right? Here are my intercepts. I cross at 0, -1, and I cross at 1, 0. Okay, looking at what we have, could you comfortably either graph and analyze or look at the table and analyze a transformation? Yeah. Okay. Let's do another one. But I'm going to pause and I would like for you, I'm gonna give you 2 minutes to do this one. So you're doing what we did on example 1 on example 2, and then we're gonna come back. I believe in you. You're welcome. Renee, can you hear me?
Yes.
Okay, cool. All right, so here we have the graph, square root of x minus 3. Draw the straightest lines you've ever seen. Look here, straightest lines you've ever seen. And I'm going to put in my parent function real quick because it doesn't take that long. So here's my PF, my parent function. And then looking at what I have f of x equals the square root of x minus 3. I have -3, which means D equals -3. So that's a translation down. Okay, so that means I'm taking each one of these points and I'm taking them down 3. And it's like, so here's my f of x. So the domain here, I'm from 0 to infinity, which means that x is greater than or equal to 0. My range here starts at -3. So my range is y is greater than or equal to -3. My intercept is what this one is focusing on, x and y intercept. Well, I can see my y-intercept. My y-intercept is where? 0, -3. Agreed? However, the problem is, can I see my x-intercept? No, I cannot see my x-intercept because it goes off the screen. These arrows mean that this is going on forever. Just because I can't see it doesn't mean it doesn't exist. So when you can't see an intercept on the graph, what you can do is solve it by hand. To find your x-intercept, that means that your f of x is going to equal 0. That means your y is going to equal 0, right? So if I take 0 and set it equal to my function, I can always find my x-intercept. You should have plenty of room. All right. So what would I need to do to get x by itself? I would need to add 3. So that cancels out the 3's on the right side, leaves me with 3 equals the square root of x. How do you cancel out a square root? Square it. And what is 3 squared? 9. So therefore, my x-intercept, if this graph would continue, my x-intercept would be at 9, 0. Okay. All right, what are your questions, comments, or concerns? Okay. All right, so for the next few examples, you either can use a handheld calculator or Desmos graphing calculator. The only hiccup is I got to make sure or double check that if you choose to use Desmos and you get comfortable with Desmos, that our test isn't in lockdown browser. Because if our test is in lockdown browser, guess what that means? Can't use Desmos. For this though, I'm not going to use Desmos. I'm going to use the handheld on my computer. But it says to graph f of x equals 2 minus the square root of x and find the maximum and minimum values over the interval from 1 to 6. Okay, so I'm analyzing not the whole graph, just from 1 to 6. Does that make sense? All right, so I'm going to graph this 2 minus the square root of x, and I'm going to see where it's a max and a min. Okay, because our absolute value function is either going to be increasing or decreasing, that means that my max and min is either at the beginning or at the end. Does that make sense? So I only have to analyze what's happening at 1 and what's happening at 6. Okay, so if you chose to do it without the calculator, you're just comparing these two values. What it wouldn't be easy for 6 because is 6 a perfect square? No, 6 isn't a perfect square, so it wouldn't be that pretty. But we're gonna do that. Okay, so let's go to graph. My handy dandy calculadora. I'm going to start a new graph. Never save. Okay, so we're going to be putting in 2 minus the square root of x. So we're going to hit enter. And like we said, we're analyzing. From here, we knew that the 2 lets us know that it was shifted up 2. See how it was shifted up 2 units? The negative lets us know that it was reflected. Do we see that? So all of that is coming to play. Now to analyze the graph, I'm going to go to menu, trace. I'm going to graph trace. My interval that I'm analyzing is from 1 to 6. So I'm going to start with 1 and find the value of 1. So here's the value of 1. And the value of 1 is 1, 1. Now I'm going to go to 6, find the value of 6, hit enter, and there's the value of 6. Can I clearly see what's my max and what's my min?
Yeah.
My maximum value is 1, and my minimum value is negative 0.45.
No.
Yes. I round it
Why is your graph going down? My graph going up.
because I put mine in correctly.
I put mine in.
You put in 2 minus the square root of x? Or did you sure? I don't think you did. All right, so our maximum took place at x equals 1, and the value was 1. Y equals 1. Where, that's your x, the value is your y. Okay. Our minimum took place at x equals 6, and the value was y equals negative and 4,500. How do you feel about analyzing the maximum and minimum of a square root function?
Wait, can you go back on
Mhm.
the menu part?
I can. So on the menu part, if you're using the handheld, it's menu. Then you're going to go to 5 for trace, and then it's 1 for graph trace.
Okay.
And that allows you to type in whatever value you need and hit enter. So we needed 1.
Okay.
All right, so next we're gonna do describing and using transformation. So normally I would like, oh, no calculator. However, I'm gonna allow you to graph if you need to, but you also can use the table to analyze. So when you're graphing, I would like for you to at least identify the transformation that's gonna take place first, okay? So if I look right here, I have y equals 2 square root of x, right? That 2 is at A, B, C, or D. Which transformation value is that? A. So we know that A equals 2. Do we see that? And because A equals 2 and the absolute value of this is greater than 1, what is happening to this function? It's a what? It's not a reflection. It's greater than 1. So we said A. And what does it mean when A, the absolute value of A is greater than 1? It's a vertical stretch. So we have a vertical stretch by 2. Okay, which means is our domain affected? Or what does that affect? That only affects our y, right? Okay, but it is not shifting it. Is it making it go left, right, or up or down? No. So our domain is still going to be x is greater than or equal to 0. Our range is still going to be y is greater than or equal to 0, which means that our intercepts are still going to be at 0, 0. Now, this is if you're using your transformations. If you're still hesitant, not comfortable, I'm going to do example B using the calculator. Is that cool? All right. So just for facts, we see here that it's something being multiplied by the square root. So that lets us know that this is our A, right? Our A equals negative 1/4. A equaling negative 1/4 tells us not just one thing, but tells us 2 things. The first thing it tells us is that it's a vertical compression or shrink, whichever one you want to write. I don't feel like writing the word compression. So it's a vertical shrink by 1/4 because the absolute value of this is less than 1. The second thing it tells us is that it's a reflection. Is it?
Oh my God.
Oh my gosh. Over the x-axis. Okay, because I did not shift left, right, or up or down, that means that my domain and my range are not being affected. So all of these are still going to be the same. I guess tomorrow we will look at how to do it in the calculator. Nope, no work until tomorrow.
You talking about phone school?
1:30.
Everybody does.